Hey, good evening. This is Mr. Doherty, and our lesson today is on factoring trinomials in the form ax squared plus bx plus c, where a is equal to 1. That means the leading coefficient is equal to 1. Now, factoring a trinomial into the product of two binomials, to do that, we need to know the following. First of all, we need to know what the standard form of a quadratic is. That's where the function is equal to ax squared plus bx plus c, where a is the coefficient in front of the x squared, b is the coefficient in front of the x, and c is the constant. It's much easier if it's written in standard form. The second thing it says here is if the coefficient of x squared is 1, then x squared plus bx plus c equals the quantity x plus m times the quantity x plus n. That means when we multiply m and n, their product has to equal c. The sum of m and n has to equal b. Now, some of you are probably even wondering, what does Mr. Doherty mean when he says to factor trinomial into two binomials? Basically, I'm taking, if I had two binomials, x plus 1 times, say, x plus 4, I would do the double distributive property and get x squared plus 4x plus 1x plus 4, combine my like terms and get x squared plus 5x plus 4. Now what this means basically, instead of multiplying them together, I'm basically going in the other direction to go from the start here to the end here. It's going in the opposite direction. Now, if I were to be asked to factor a trinomial, I'm going to pick a nice one to start with. Let's say I started with the example x squared plus 9x plus 18. That's in standard form because a is 1 in front of the x squared, b is 9, and c is 18. What I need here is I need numbers that multiply to 18 and add up to 9. So what I'm going to do here is I'm going to list all the factors of 18. It's a positive 18, so I take two positive numbers and multiply them together. They're going to add up, hopefully, to 9. So they're going to multiply to 18 and add up to 9. Sometimes I do it like that so I know which one I want to multiply to and which one I want to add to. Eventually you'll be a pro and you won't need that. But let's take the factors of 18. I have 1 and 18. That's an obvious pair of factors. They add up to 19, so that's not the answer. Let's see, does 2 go into 18? If I divided 18 by 2, I would get 9. 2 and 9. 2 plus 9 is 11. Okay, that's not the answer either, but it looks like I'm getting closer. Does 3 go into 18? Well, 3 goes in 6 times. 3 plus 6 is 9. It looks like I've found my answer because 3 plus 6 adds up to 9. This means I can factor this as x plus 3 times x plus 6. Now, by the commutative property of multiplication, it makes no difference whether I put the x plus 3 first or second, as long as I show that they're multiplied. They must be in the parentheses. You may notice this here, that the first two terms multiply to x squared, and the last two terms, the 3 and the 6, multiply to 18. We can confirm this is our answer by doing the double distributive property and see, well, if we distribute the x times x, that's x squared, plus x times 6 is 6x. 3 times x is 3x, and 3 times 6 is plus 18. Well, this combines to be x squared plus 9x plus 18, so this was an effective check. We'll make that look more like an 8. That was pretty bad. So we did a check there. We did a nice, simple example. Let's try another example. It's very close to this one. Let's try x squared plus 19x plus 18. I have the same setup as before. I need numbers that multiply to 18, but they have to add up to 19. Well, I can actually use the table from above. Once I find my answer, I don't need to go any further. I got 1 and 18. What do 1 and 18 add up to? Oh, they add up to 19. Very good. So we can write this as x plus 1 times x plus 18. The two numbers added up to 19, which is what we wanted. Now, certain cases won't work. I'm just going to do this off to the side here. Let's say I had x squared plus 12x plus 18. There are no factors of 18 that add up to 12. It would have fallen in between here somewhere. So something like x squared plus 12x plus 18 does not factor. It only factors if the c value, if the two factors of the c value add up to the b value. Well, you may have noticed that these examples both had positive numbers. Is it possible to get numbers that multiply to be positive 18 but add up to a negative number, say negative 11? Well, the same, if two numbers have the same sign and we multiply them together, they'll end up being positive. So a positive times a positive is obviously positive, but a negative times a negative also gives you a positive. So it's going to multiply to positive 18 and add up to negative 11. We're going to have two negative numbers. So let's try negative 1 and negative 18. We'll see that's negative 19, so no. But negative 2 and negative 11, excuse me, negative 2 and negative 9, they multiply to positive 18, but they add up to negative 11. So we found our answer there. So we can have x minus 2 times x minus 9. And again, if we were to check this, we would see, oh, we did the double distributive property. Now we get x squared minus 11x plus 18. Our work checks. This is awesome. But they both could be negative. Now, I want to stick to my 10-minute rule. I only got a minute and a half left. Try this, pause the video, and I'll put the answer up so you can check it. 3, 2, 1, pause. When you open this up, the answer will be there. Okay, the answer has now appeared magically. The answer was x plus 3 times x plus 7. I made the table over here. Luckily, 21 didn't have too many factors. 1 and 21 add up to 22. 3 and 7 add up to 10, so that's what it's got to be. Now, 4, 5, and 6 were not factors of 21. When I tried 7, I noticed I got 7 and 3 again. I already had that, so I didn't need to do that. 3 and 7 is the same as 7 and 3. I'm going to put a couple more up for you to try, and I'll do the same type of pausing. So I've added 3 more problems for you to try. The first 2 are relatively easy. The third one has kind of bigger numbers. But if you're methodical and you go down the list starting at 1 and work your way up, or negative 1 and work your way up, you should get it. We're running short on time, so I'll pause the video and then the answer will appear. 3, 2, 1, ta-da. So here are the tables where I've showed my work. I'm fairly certain I know students are going to ask me, do I have to show my work? I'm going to say yes until we've mastered this and you've proven you've mastered it, but eventually many of you will get to be good enough that you won't need to make this table. But for now, I really want you to do it because when you run into those really tough ones, you're going to want to be able to resort to using the table. Thank you for listening. Please make sure you understand this, as this is one of the more important lessons you'll learn throughout your high school career. We will talk about this again in class tomorrow. Have a great evening. Bye.